Alright, so today we are going to jump right into chapter 5, section 6. This is actually going to be, I'm just giving you a heads up, this is probably going to be a long lesson. There's a lot of content here that we really need to go through. This is very, very important material. And the reason why is it continues to appear time and time again. It will show up over and over and over and over again. It's very valuable for you if you plan to take college algebra, so that's why I do not want to skimp on this lesson. I do want to take as much time as I possibly can take. That being said, I'm probably not going to go through all of these notes in very fine detail, and part of the reason why is I write out more of a procedure for you to follow here, and you can see an example specifically for what I do. But what I'm going to do is I'm probably just going to work out a bunch of problems. I'm just going to go into the problems and start working on them. And really the two things that we're doing is we are factoring things that look like this. So in other words, if you have x squared minus 3x minus 10, what does it look like if you were to factor it? The previous section, they made it really easy on you by splitting it into groups. Into grouping. We're actually going to return back to that a little bit later in this lesson because that is a very valuable way of dealing with more complicated trinomials. And so, again, this is just a procedure you can follow. I just wanted to write it out for you. Here I list out specifically an example, x squared plus x minus 12. And then, again, just another procedure. So we're looking at this value, the very last thing, the coefficient, or I'm sorry, the constant term. So minus 12, and we're looking for all the factors of minus 12. So I list them all right here, minus 1, 12, 1, minus 12, and so on. Okay? Then what we're doing is we're looking for what each of those factors will add up to. So if I were to combine them and add them, I get plus 11, minus 11, plus 4, minus 4, plus 1, minus 1. Now, the thing is, if I look at the middle term here, this guy right here is what I'm looking for when it comes to adding. So I do all the factors by multiplying to figure out what these are. I found them here. And then the adding, I want whatever I added those factors up to equal what this coefficient is in the middle term. So basically we're looking for a plus 1, okay? And if you look right here, it's going to be this guy. So that means that the factors are going to be minus 3 and 4, which means that we will write it like this: x minus 3, x plus 4. Okay? Again, this is a really kind of long and drawn-out process. As we go through these, I'm going to expect that you can do this mentally. I will try to do a few of these mentally so you can see my thought process. I'll speak it out loud so you can hopefully mirror in your own brain and process it. So that's the goal. These are the more simple ones because we're doing just x squared plus bx plus c, which is the first part. The second is when we have a coefficient in front of the leading term, which is going to be right here. So if we've got more complicated numbers like this guy, okay? One thing I do want to back up on, just note to you really quick, the textbook has a very long and arduous process of doing something called multiplication or by trial factors. Just, I don't know why they put that in there. It's really inefficient. I'll just tell you that right now. It's very, very inefficient. It's not very helpful. It's more convoluted. I am not going to even look at that stuff, okay? Because it's just going to take a lot of time. And they don't really do a great job of explaining it. So we're going to skip that, and I'm going to show you the more simple way of doing it and the less convoluted way. So for situations like this, where you've got a coefficient sitting in front of your leading term, what we actually have to do is just add an extra step in. there's a cool trick that you can do where you multiply the coefficient of the first term times the constant. So A, in this case, A times C. So A is equal to 10, B is equal to 11, C is equal to 3. So when we do A times C, we actually find that this is equal to 30, positive 30. Okay? And similarly what we did above, we take the product of those numbers, which is 30, and then we try to find all of the factors of that number. Okay? So we have 1 and 30, the negative factors as well. You know, you can work it all out. When you add them all up, you're going to get all these numbers. Now again, we're doing the exact same thing we did previously. We're going to try to find the thing that matches. The sum is going to match that middle term, that B value. And when you do that, you find that the numbers are going to be 5 and 6. So what we are going to do is to actually rewrite the original equation using the factors that we have here, but we're actually separating them by grouping, kind of like what we did last section. If you don't remember how to do that, I encourage you to go back and check out the video because it's going to be very helpful in this section. So the middle term is 11. The factors are 5 and 6. We're going to group them. So take a look at what we do. We change 10x squared plus 11x plus 3 into 10x squared plus 5x plus 6x plus 3. Notice if I were to add these up, this right here would equal this 11. All I'm doing is I'm just separating them into two separate pieces. And like we did in the last section, if you put brackets around the first two terms and the last two terms, what you can do is then factor again. So you can pull, in this case, the common values or the common factors that you're pulling out of both of these pieces is going to be 5 times x. So the 5x gets pulled out, and then I multiply by whatever's left. I do the exact same thing here. The common number between 6 and 3 is going to be 2. But I can pull a 3 out, so I'm going to pull the 3 out, and I'm left with a 2x plus 1. Now that I have these things right here, the 2x plus 1 and this 2x plus 1 equal to each other, they're exactly the same, I can actually group by combining this leading term here, this coefficient, this 3, and this 5x together into a single term. Okay? So this guy is coming from the 5x and the plus 3. Okay? That is, again, I just went through this entire section super fast. I'm going to go through a ton of examples here, so hopefully this all makes sense. Let me go ahead and bring up my whiteboard here. And again, I'm going to, as we go through this section, I'm going to try to use some mental math, the way that I start thinking about some of these problems, because honestly they really do help when you're able to do them a little bit more quickly, just thinking through them. So let's start off with question number 12. Question number 12. We're given a squared plus 7a. My marker is shot. Let me get another one. And here we go. A squared plus 7a plus 6. There we go. That's much better. So what we're doing, I'm going to do this the long way, and then as we start going through these, I'll probably speed it up. So what we're doing is we're looking for, in this case, the factors of 6. Okay? And you can write it out like this. This is how the textbook actually shows you to do it. And then whatever factors we get here, we're actually just going to sum them over on the right-hand side. So factors of 6, we'll start at 1 and work our way up. 1 and 6. We also have to do the negative factors as well, because a minus 1 times a minus 6 is also a positive 6, so keep that in mind. 2 and 3, minus 2 and a minus 3. Okay? So now I'm just going to add across. 1 and 6 is going to be 7. Minus 1 and minus 6 is a minus 7. Okay, I'll give you a little hint. Usually these numbers right here will be, you'll see them in pairs, and one of them will be negative. Okay, 2 and 3 is going to be 5. Minus 2 minus 3 is a minus 5. Okay, now once we've done this, we found the factors, we do the sum, we're going to look at this middle piece here. So the plus 7 is what we're looking for, which means we are specifically going to be using this guy, whatever factors coincide with the sum that's equal to 7. So here are the factors that we're using, which means right off the bat we can go ahead and factor a plus 1, and we also have a plus 6. Okay, and that right there is going to be our final answer. Now I will say something real quick. When you look at this problem, the way that I would mentally do this if I were seeing it and I needed to factor it, I would think of 6 and then just think, okay, what combination of factors will give me a number that's equal to 7? So just by looking at it, I can tell that it's going to be 6 and 1. Okay? And again, we'll do some more complicated ones so you can hopefully see my process, but this right here is going to be the final answer in number 12. Okay? Let me go ahead and erase, and we'll go ahead and work through the next problem. Question number 22. I've got x squared plus 5xy plus 6y squared. Okay, these ones are a little weird because you have x's and y's all thrown together. If you encounter a problem like this, I'm going to tell you this flat out. Ignore the y's. Just ignore them. Pretend they don't exist. Okay? So, imagine that this is the number that we're working with. Okay? We're going to bring the y's back in the end, but we're not doing it right now. So we're going to look at factors of 6, and we literally just did this the last question. So the factors of 6 in this case are going to be 1 and 6, minus 1, minus 6, 2, 3, minus 2, minus 3. My lines are not really that straight. Okay. So now we add across. 1 plus 6 is equal to 7. Minus 1 plus a minus 6 is a minus 7. 2 plus 3 is going to be 5. This is going to be a minus 5. Okay. So again, what is the middle term? In this case, it's a 5. So we're using that one, which coincides with these factors. Okay? But how do you factor something with x's and y's? Well, that's a good question. The trick here is that you can use grouping just like we did before. But honestly, the easier way to do this is just to throw the variable in on the last term. Okay, so basically what you have is going to be this. X plus 2, and then you just throw the y in. X plus 3, throw the y in. Okay? That would be how I would do it. And in fact, that is the correct answer in this case. Now, yeah, I'm going to leave it like that. You just can do it like that, and it shouldn't be too much of a problem for you. I'll just keep it simple. No need to make it complicated. That's my motto for today. All right, number 25. Like I said, we're going to go through a lot of problems. So take your time, go through these, slow the video down if you have to. But I definitely want you to make sure that you understand this. Don't just move on and do the homework assignments without understanding it. Understanding is the goal. If you don't understand it, don't do the homework assignments. Figure it out until you keep working it until you figure it out, and then do the homework assignments, okay? So in this case, we've got x squared minus 7x minus 12. We're going to look at the minus 12, and we want factors of that number. And then lastly, we are also going to be looking at the sum. So let's do 1 minus 12 minus 1, 12. 2 minus 6 minus 2, 6. 3 minus 4, and then minus 3, 4. Okay, so you can see I'm doing all the combinations of positives and negatives. Quick little hint, when you get to the bottom here, you notice how these are only separated by one number. Separated by one number, or digit, I should say. So when you get to that point, notice that you can't do any more factoring, because you can think of, I'm doing increasing factors. 1, 2, 3, 4 is over here, so it's 4, 6, 12. So you basically already did it, okay? So when they're separated by 1, you're pretty much done, or less. It could be that they're, you know, if you have like 5 and 5 is 25, that would be the same. So okay, let's do the sum now. So minus 12 plus 11, or sorry, plus, this is minus 11. Getting ahead of myself here. This is going to be positive 11, minus 4, positive 4, minus 1, positive 1. Okay? So again, we're going to look at this middle term, and you notice that nothing matches up. Okay? Nothing matches. That is important. Since there's no sum over here that matches that middle term, we call this non-factorable. Okay? You cannot factor it. However, there is a procedure later on in this class that we will work through called the quadratic equation that will solve this for us, and it may produce something called an imaginary number. Okay, so we will not be there right now. For now, if you see something that looks like that does not give you a sum that matches that middle term, then it's considered non-factorable. Okay? All right, I do want to look at number 32. One of the things when you start to see coefficients in front of your leading term, so when I say leading term, I mean the first term that is sitting in front of your variable, the highest variable. You may encounter situations where it's wise to actually factor before you work out the next step. Okay. So when I look at this problem, you'll notice I have a number there, and if you go by the procedure that I mentioned in the notes, you would do A times C is equal to 5 times 140, or negative 140 I should say, which is going to equal a negative 700. I don't know about you, but that list is absolutely insane when it comes to finding the factors, and I frankly do not want to even touch it, okay? It's going to be bananas probably. So what we are going to do instead is we actually, looking at the very initial problem, you can actually factor a 5 right out of the initial problem right off the bat, okay? This is going to make your solution so much easier to work with, okay? Or your problem so much easier to work with. So I can pull a 5 out. Now if I pull a 5 out of this first piece, what's remaining? Well, I just have x squared, Okay. If I pull a 5 out of 15x, what's remaining? Just a 3. 3x. Pulling a 5 out of this last one is going to ultimately give me you can do this in a device if you need to, but it's going to be 28. Okay. I'm not that good. I'm pretty sure I had to use a calculator for that one. So 28 times 5 is going to be 140. And it's negative, so that's where the negative sign comes from. Now, what we can do is we can actually work with just this last piece here and find a factor for minus 28. So now we do the exact same thing. Factors of minus 28, and then we do the sum. Okay. So in this case, the factors of minus 28 are going to be 1 and minus 28. Minus 1 and 28, positive 28. 2 and 14, minus 2 and positive 14. You can see they're just flipping signs back and forth. Does 3 go into 28? No, it doesn't. Oh, by the way, there's a little trick for that to know if anything is divisible by 3. You take these two numbers, 2 and 8, or I should say over here, 2 and 8. You add them up and you get 10, and 10 is not divisible by 3, therefore 28 is not divisible by 3. Okay, little trick there for you to figure out if something is divisible by 3. If I had a 27, 2 plus 7 would be 9, and 9 is divisible by 3, so 27 would be divisible by 3. But 28 is not. So we can skip 3. We can go to 4. I think, yeah, 4 and 7 I think is going to be minus 4, positive 7. And I think that's it. 5 doesn't go into that because it's not a 5 or 0 at the end. It's not 6. 6 doesn't go into 28 because 6 times 3 is 24. So the next one would be 30. 6 times 5 is 30. So it's not, 6 isn't a factor. So I think we're done. Okay, so now let's do the sum. So this is going to be a minus 27, positive 27, minus 12, positive 12. 4 minus 7 is a minus 3, and then this is going to be a positive 3. Okay, now we look there. Positive 3, those are our factors. So in other words, 5 times x squared plus 3x minus 28 is equal to 5 times x minus 4 times x plus 7. Okay? Another way that I like thinking about them, okay? I want to show you a different way that the mental way that I would do this. The very first thing I would do is the same thing. I would factor that 5 out. I'm going to erase this though and show you the different way, the more mental way of doing it. Okay, so I know that 28 is the thing that I'm going to be looking at here, and what I want to do is figure out a way to multiply two numbers together that are going to equal a difference of 3 or produce a difference of 3. So you can literally just list out, and my camera just shut off, so just give me 1 second. I will pop that guy back up. I assumed this was going to happen if I had a long video. So as you can imagine, it has happened. Alright, 1 second here. Alright, let's try this again. So, I'm going to look at 28 and think about combinations that are going to produce 28. Okay, so I'm not even thinking about positive and negative signs, okay? 1 and 28, 2 and 14, 3, oh, we just said 3. Nope, 3 doesn't work. 3, 4, and 7, okay? Now, I'm not even, like I said, I'm not even thinking about the positives and negatives. I'm just thinking about the numbers, okay? Any combination of these numbers is then going to have to produce a 3. So I know that a 4 and a 7 will produce a 3 if one of them is negative and one of them is positive, okay? To figure out which one is negative and which one is positive, this is the trick. So because the 3 here is positive, the bigger one over here is also going to be positive, okay? So if this term right here is positive, the bigger one over here is going to be positive. If it's negative, then the bigger one is going to be negative. Okay, so you can kind of match it up. So in this case, I know right just from doing that little trick, oop, that's squared. What am I doing? X squared. I know right off, what am I doing? Hello, I'm writing the factors out. It's been that kind of a day. I know the bigger one is going to be positive, so this is going to be plus 7, and then the smaller one is going to be negative. And sure enough, that's exactly what we got. So that's kind of the way that I would do it more mentally. I literally just list these things off and think about every possible combination over here, just excluding positives and negatives. Okay? If the combination or if any combination of those could produce that number, then that's exactly what I'm going to use, and then I'll figure out the signs after. Okay? So I hope I can show you another example of that. Yeah, actually we can. Let's just do that. So I wrote out the long way. You can go back and watch those. I'm actually going to do that the more quicker way again on this next problem. Okay, 34, 4x cubed, y cubed, plus 56 x squared y cubed plus 180 x y cubed. Okay. So again, this is one of those situations where we have to do some initial factoring. I'm going to look at the leading term and then try to find all of the possible pieces that are common among all of them. So 4 goes into every single one of these numbers. There is an x, so it would be, this is x to the first, that's the smallest one, it sits inside of all of those, and then there's also a y cubed. So I'm guessing that the initial factor is going to look like this, and now we have to figure out what's left. So this is going to be, we pulled a 4x y cubed out of a 4x cubed y cubed, so looks like x squared is remaining. 56 divided by 4 is going to be 14. And it looks like we're missing an x. And then over here, this is going to be a 45. And both of these are actually pulled out in front as well. So, okay, so here we go. 45. Let's just look at the numbers, the combinations, okay? Just write out the combos. So 1 and 45. 2 doesn't work. 3 does because 5 plus 4 is 9. So 3 and 15. 4 doesn't go into 45. 5 does. 5 and 9. Okay. Now, I'm trying to get 14. So I can't do any kind of combination here. That's definitely not going to equal 14 if I add or subtract any combination. Add or subtract any combination of 15 and 3. I can get an 18, I could get a 12, but I can't get a 14. There's just no way. Here I can. If I add 9 and 5, I'll get 14, and that is exactly what I want. Okay? So again, I'm not even looking at the signs. I'm just trying to figure out what combination, if I add or subtract these, any kind of combination of them, what will they produce? So in this case, both of these numbers have to be positive for that to work. And in this case, it actually works because everything is positive inside my equation. So we'll rewrite this: 4xy cubed times x plus 5, x plus 9. So there it is. Okay. If you want to multiply this out and test it, you can. What you're going to get is 5x plus 9x, which is equal to 14x in the middle as your middle term. And that's pretty much it. Now, if you wanted to go the longer route, I'll show you really quick. You're going to get the exact same thing. 1 and minus 45, minus 1 and 45. We'll do 3 and 15, minus 15, minus 3 and positive 15, 5 and negative 9. Wait, why negative? Hello. Oh, I'm sorry. Hang on. See, this is why I don't like doing that. These are both negative. They both have to be negative at the same time. There we go. Minus 5, minus 9. Okay. And then this is going to be 46, minus 46. 18 minus 18, 14 minus 14. Okay, so again, there it is. So this is the longer way, but the other way that I showed you just takes a little bit of just mental processing. You kind of have to think through like how the numbers add up. But I do want to get you comfortable being able to do that in this class. Okay. All right, let's go ahead and jump to number 54. Number 54. Now, the book shows you two different methods to do this. I am not. I'm going to show you one method. I think I included in the notes, if you want to look at the PDF that I screenshotted and put on Canvas, you can go ahead and take a look at that, but I'm just going to show you the second method here because it is far easier to work with, in my opinion. Again, this is just my opinion. But all right, so 54 says 4a squared minus a minus 5. Minus 5. Okay. So the trick here is that we need to recognize that a is equal to 4 and c is equal to a minus 5. It's kind of weird that they have a and a squared here, but all I'm using for the a's and the c's is to represent the coefficients that are sitting in front. So if I did b, it would be a minus 1. Okay? So a times c is equal to a minus 20. And now this is specifically the factors that we need to find. We need to find factors of this in order to find the appropriate way to group this. So it's the same process as before, factors of minus 20. The way that I just showed you to do it, it works for the more easier ones when you have a leading coefficient in front of your leading term, or you have a coefficient in front of your leading term. It's going to be a little more tricky and challenging, so you might want to just use this method. Okay, so factors of minus 20, we'll start at 1. So 1 and minus 20, minus 1 and 20. We'll have 2 and minus 10, minus 2 and positive 10, 3, no, 4 and minus 5, minus 4 and 5. Okay, so this is again the long way, but I want to make sure I get this right, so that's why I'm doing it. Now when I sum these, I'm going to get minus 19, positive 19, minus 8, positive 8. You don't need the positive sign, I'm just putting it in there. But minus 5, this is going to be a minus 1, and then this is going to be a plus 1. So again, we're going to compare the coefficient. So b in this case is equal to a minus 1, and we want that to match this. So this is what we're using. Okay, 4 and the minus 5. We are using 4 and minus 5. Okay, this is where things get a little tricky. And the reason why is because we are going to be doing something called grouping. We did this the last time, the last section. So I want to show you how to do it in this case. What we're doing is we are going to be taking this middle term and splitting it into two separate pieces, which are made up of these two factors that we just found. So in this case, we are going to do a plus 4a minus 5a minus 5. Okay? And now I'm going to rewrite them, but I'm going to do the brackets in front. And I'm going to bring the minus sign out in front. I did this last time. And I'm going to make this second one positive. Remember, this is the trick. If I pull a minus out, that has to become a positive. So now we look at just the two pieces separately. So this piece here, and this piece here, we're going to look at them both separate. So what I'm trying to do is find what's a common factor between these two terms. It looks like there's an a inside of both. There's also a 4, so I can do a 4a, pull that out. And I'm going to be left with an a right there. 4a, I'm pulling a 4a out of a 4a, which means I'm left with a 1. Okay. Over here, it's the same idea. I am going to pull out it looks like a 5, and then I'm going to be left with an a, and a 5 times what is equal to 5? That's going to be a 1. Okay. Now, we're almost done. When you get to this point, you'll notice that I have common factors right there. And when you have two of these things simultaneously, almost like back to back, I can combine what's leading in front of it as its own factor. So in other words, this becomes 4a minus 5, a plus 1. Now, again, this only works when these are exactly the same. If they're different, then it's not going to work. These factors need to be identical. All right, that is that problem. Let's see here. Oh, I should point something out. You may notice, so check this out. I want to point this out to you because some people are going to be like, oh, like what if I get the order wrong? You know, if you put these backwards, you're still going to get the same answer, surprisingly. So if I do, check this out. Instead, if I do 4a minus 5a plus 4a minus 5, again, so these two middle terms here, it's exactly the same. I just changed the order, okay? And you can do the grouping just the same. So 4a squared minus 5a. This one actually might be easier to do than the way that I did it. 4a minus 5. Okay? So what you're going to do is you're looking for what's common in these pieces. It looks like there's only an a. And I'm left with a 4a minus 5 plus, and in this case there's nothing in common between them, so this is just a 4a minus 5. But notice how there's a 1. You can think of that as being like a 1 right there. So now since these two are the same, I get a plus 1 times 4a minus 5. And take a look. It's exactly the same. So again, the order doesn't really make a difference when you're doing the factoring by grouping, which makes it really nice. because you can actually, there's some cases where it actually might be easier to group it than, or to factor it by grouping than if you were to go about some other convoluted mess. So just a little thought. All right, let's look at question number 58. Question 58. 12x squared. I might return after these problems. I might just look a couple up in the textbook and do some of those more mental math ones just so you can see another couple of examples of how I would do them. But let's just work on this one first. Okay. 12x squared minus 40x plus 25. All right, so 12, 40, and 25. It doesn't look like I can factor that 12 out, so I have to go with the AC method, the air conditioning method. I'm just kidding. AC, get it? My lame dad jokes aren't really that hot, apparently. 300. 12 times 25 is going to equal 300. Okay. So we are going to look at factors of 300. Oh my gosh. Do we really want to do this? We really don't. I'm going to show you a little hack, life hack here, okay? We are looking for something that is going to produce a minus 40. So, check this out. You can actually see a little bit of a pattern here. I should have not erased that last one, but alas, here we are. Minus 1, minus 300. 1 and 300. Okay. Minus 2, 150. Minus 150, sorry. 2 and 150. Okay. Minus 301, positive 301, minus 152, positive 152, if I add them all up, so on and so forth, blah, blah, blah. One thing that you will notice is that as you go down the list of factors, the sum, I'm going to call it the magnitude, so the size of the digits are actually decreasing. You'll actually find this across the board for every single one of these problems. Your highest difference or sum is always going to be at the very top, and the lowest is going to be at the very bottom. So we're kind of approaching this problem in a bit of a backwards way. You can think of it like this. I'm trying to find this right here, the minus 40, and I want that over here. Okay? So I am going to do, let's pick a middle point. Let's do 10, for example. 10 and 30, well, that equals 40. How about that? Minus 10 and minus 30 is equal to a minus 40. So that right there. So you don't have to do all the factors. If you just figure out the two where the sum is going to equal that number, then you're solid. You're good. So minus 10 and a minus 30 is going to be the two numbers that we have. So let's do our grouping just like we did before. 12x squared minus 10x. I actually in my notes did it the opposite, but I want to try it this way because it just seems like fun. Yes, math can be fun, believe it or not. It's really fun when you actually get it too. That's when it's the most fun. Okay, what is common between a 12x squared and a 10x? So, 2? I think a 2 can go into both of those. And an x. Well, let's do my grouping. Hang on a sec. Blah, blah, blah. Minus 12, minus 10x. Minus, ooh, there's a minus. Keep that in mind. Minus 25. Remember the sign flips if I pull a minus out in front. Okay. Okay. Let's see here. I can pull a 2 in front and an x. So what's left over in the 12x squared from the 2x is going to be a 6 and an x. And then over here it's going to be a minus 5. Yeah, I think that's it. Okay, so here it's going to be a 5, right? So 6x minus 5. There we go. So now that these are the same, I can combine them. So I get 2x minus 5, 6x minus 5. Okay. If you really master this section of content, I'm going to tell you right now, you are going to do very, very well in future math classes. Okay. This is factoring. I will. Here's something I actually used to do when I used to teach at KU as a TA, a teaching assistant. I taught a calculus class, and one of the things that I told my students when the very first thing that they would do when they took calculus, some of them wanted to go and become engineers, and so I literally the very first day of class I would give them a quiz on FOIL, and if there were students who could not FOIL, I pretty much told them that you should consider going and looking at another profession, because engineering is a very difficult topic, and there's a lot of math involved, and if you get to the point where you're taking calculus and you're not comfortable with foiling, then you probably should not become an engineer. I'm hoping that I saved a lot of people time and money in doing that, but you never know. I'm crushing people's dreams of becoming engineers. But I think the thing is, it's like you have to just know what your skills are and where you're at. And the challenge with that one is because a lot of people go into that class and they want to do certain things that require a lot of extensive mathematics, and you may already be behind the curve just a little bit when you are trying to get into a profession. It's like you're going to struggle. So just let's rip the Band-Aid off this thing, and I don't want that to be the case. Okay, let's go ahead and look. Oh, yeah, let's do this one. I'm going to go backwards again. So this is kind of, if you already got to this point, you don't have to watch any further, but I just want to go through a couple more examples. I'm going to do the more mental math way of doing these, the way that I would do them, okay? X squared plus x minus 132. Okay, so this is like, oh great, 132. Here's the thing. So again, I'm thinking of 132, factors of 132 that give me a number that is 1. Okay? What does that mean? So let's analyze this and think about it before just trying to write everything down. You can brute force these all you want, but it's much more interesting if you think through the process, okay? Minus 132, ignore the sign. Ignore the minus sign. So 132. We're looking for a combination of numbers that ultimately could produce 1 as a sum. In other words, what that means is that the numbers are going to only be 1 apart from one another, okay? So just looking at this, I can tell what it is right off the bat. If you don't know your factors of 132, then that's probably the case. I do. So I know that 12 times 12 is 144, and 132 is 12 less than 144. So that's how I know that it's going to be 11 and 12. Okay? Again, this is just me doing the mental math. So 11 and 12, I have a negative sign there, which means that the bigger, since this is positive, this one is going to be the positive one. That one's going to be the negative one, which means I get x minus 11 and x plus 12. Okay? So that is the fast way of doing it. So if I wanted to do let's look at the factors. 132, there's a lot of them. If you remember the pattern that I showed you over here, just the last question, as you work down, let me do that. I want to show you that really quick. So if I do the factors of minus 132, I'm going to do the really long way here, and then we'll look at the sum. Okay? So factors of minus 132, we'll have 1 minus 132. I hope I don't run out of space here. Minus 1, 132, 2, and, oh gosh, 66? Yeah. Minus 2 and positive 66. 3 is in there too. Oh my gosh. This is nuts. 3 and 44, I think. I think it's minus 44. I'm just guessing at this point, so I'm pretty sure that's correct, though. 4. Oh gosh, this is where I'm going to have to use a device. All right. Take a little break. 132 divided by 4. 33, of course. Minus 4, positive 33. Okay, you can see I'm just going a little crazy. I'm not going to go all the way down to the solution because it's ridiculous at this point. I'm just going to be working forever. So let's just go ahead and do the sums, though, because you're going to see an interesting pattern that comes out of this. Minus 131, positive 131, minus 64, positive 64, minus 41, positive 41, minus 29, positive 29. Okay, take a look really quick at those numbers, okay? Do you notice how the magnitude is decreasing? I think I said this the last question, but this is a good problem that really illustrates that. 131, 131, 64, 41, 29, and it keeps going down and down and down, okay? This is the number that you're looking for that is right here. So I'm trying to find one that's just going to literally be 1. That's why I picked 11 and 12, because I know that they're separated only by 1. And then based on the signs of the problem, you can figure out what the signs are. So that's, again, just this is kind of an insane question, but if you know the principles, you can actually do them pretty quick mentally. Let me go ahead and do, I want to do just like a normal one that's not completely bananas. 15. Yeah, let's do that one. 16's good. 16's a good one. Okay, I don't need this. 16. Okay, we're going backwards here. The basic questions here are really, really good practice ones. Okay, because if you get these principles down, they're really, really helpful. All right, so x squared plus 15x plus 50. All right, so I'm thinking of combinations here that are going to produce 15. Multiplication, so two things multiplied together that will add up to be 15. This is probably, I already know it. I should, 5 times 10 is going to be 50. 5 plus 10 is going to equal 15. So, I mean, in this case, it's just literally 5 and 10. So here it's going to be x plus 5, x plus 10. Okay, there it is. So that's, again, just another way of doing it really quick. I know the signs aren't negative because every sign here is positive. So that's a nice way to do it. That one was really lame. Let me pick another one because I want to show you just, yeah, that one was just a little too lame. Let me do the next one, 17. X squared plus 4x minus 5. Okay. This one's easy because, well, okay, this is another easy one. This is a prime number, so it's literally going to be 5 and 1 are the factors, and you just have to figure out what combination. So this is where it gets a little tricky because this is negative and that's positive, which means one of these is going to be negative. To know which one it is, you look at the sign of this guy, and because that's positive, the bigger value is going to be positive. So that means this one's negative. And again, my camera just shut off twice in one lesson. Man, I must be going on forever here. we go. All right, bring this back up. Boom. So I know the minus sign is going to be connected to the smaller value, which means that my factors are going to be x plus 5. Okay. I know it feels really scatterbrained. That's a 5, not a 6, by the way. 5. It feels kind of scatterbrained, but again, take a look at some problems. There's like all kinds of examples. Literally just do a search for like quadratic factoring on Google, like quadratic factoring worksheet or practice or something like that. Hopefully what you can do is you'll see the solutions there, but try ignoring the solutions and just working them out using kind of this method, right? So you look, you think about the numbers, the multiplied numbers together that could produce whatever the sum in there is, and then you can figure out the positive and minus signs based upon the sign that's sitting in front. And that's basically it. Again, I've been doing this for such a long time that I've almost perfected it down to a science. For me, I know what works for me. I know how to get the correct answer pretty quickly, as you can see. But you have to start somewhere. And so if you want to go through the slower process, that's fine. I don't have a problem with that. I want you to get the correct answer. So take your time, do what you need to do. If you need to work through it and write everything down, that's completely fine. For those of you who wanted to see a little bit more of a quick process in the way that I think about these problems, then I wanted to show you this. So that is all we have for today. We're at 56 minutes. We're approaching an hour. So I hope this has been helpful. But aside from that, that is really all we have today. Have a good one.